Hi, in this video, we want to take a look at getting started with ggmap in R. All right, so the big advantage of ggmap over other options is that for plotting maps is that one, we get the power of ggplot, and two, we get to take advantage of Google. And Google's map features are very, very powerful. ggplot is very, very powerful. We're taking them together, and we can get some really good, solid, strong mapping results, data visualizations very easily with this method. Okay, so now the first thing that you're gonna have to do to use this is you're gonna need to get a Google API. Now, this is where certain things kind of go sideways, is that Google relatively recently started charging you money. Previously, you would be able to use a Google API, and if you had a small request, they would go ahead and just let you do everything for free. Once you exceed a certain point, they're like, hey, give us some money. Let's get the credit card going. Now, Google's a business, so I don't begrudge them for it. I am disappointed. I prefer the free version. That was better for me. It doesn't cost that much. I think it's worth it. Geocoding can get expensive though. All right, so geocoding is where you take an address and you convert it to latitude and longitude. There's also reverse geocoding where you go with latitude and longitude and convert that to an address. So those features, if I'm doing an entire data set, could get expensive relatively quickly, but regular map use, like a map here, a map there, like what I'm doing today, isn't going to be that big of a deal. Just be mindful of it as you proceed through. Okay, so let's go ahead and register my Google API. All right, so what you have to do before this step, you have to go over to Google, you have to register for an API, you have to create a project, and you have to get an API key. It will be a really long character string. And also, you have to have like a credit card on file with them or some form of payment linked up with that account so that they can charge you when you make requests. So I'm not going to go over how to do that here in a YouTube video, because my impression with this is that Google is kind of, they're always changing, they're always updating, they're always improving, and anything I do will probably be out of date by the majority of the time if people are looking at it. So I'm not going to talk about it, but you do need to get a long character string API that with Google that is connected to a funding source. Okay, so now here, I'm just going to say display 5 digits. I think 5 digits is good for latitude and longitude, because everything that we're going to be doing, the latitude and longitude will always have its first 2 digits the same, 28 and -81. And so 5 just takes us out a few more. Now, I don't like it when my latitudes and longitudes get displayed in scientific notation. Doesn't make sense to me. So I am I'm asking R to not use scientific notation with the SciPen option. Now, when you register your Google API, what you're going to need to do is, actually, I'll scroll down. In the ggmap package, you need to go to, you need to use register Google, and you need to have your key. That'll be your Google API, and you'll pass it right here. Now, you'll notice that I didn't display mine because I don't want somebody on the internet taking mine and running up a bunch of charges on my credit card. So how I am handling it is I stored my Google API in this file location, and then I just read it in. So I read in just the one entry on this file, and I'm defining that to be my Google API. Now, while I'm working on this, if I was to print this object, it would print out my full Google API. And I'm going to load the ggmap package. All right, so if you watch my other videos, you'll know that I avoid using library and require. I avoid loading packages because I prefer, if I'm only going to use one function or a few functions, I'll use double colon notation instead. Here, I am going to go ahead and load the whole thing because this package works better if you load everything. And you'll notice that automatically gets ggplot 2 going for us. So we get the, because we're going to be using it. All right, let's do a quick and easy map. All right, so what I'm going to do, I'm going to specify longitude and latitude. So remember, longitude, we're going to represent on our x-axis. Latitude is our vertical axis. It's reverse of how we word it. And I'm going to specify the location. I'm going to specify the zoom. Bigger zoom, the smaller region will be on your map. The more zoomed in you'll be. And this says how much detail will be in the picture. So I'm going to use the getMap function. So what this does is that this gets the map from Google for me, and I will be charged for this. And then this command, this ggmap function, goes through and actually renders it as a plot. So this function gets the map from Google. This function renders it and makes it a visualization. And we see where it's using Google API. It's grabbing a static map. And here is latitude and longitude. And so here we have a nice little map. All right. So we can see it's around Central Florida is where it's centered. Now, one of the reasons why it's good to use Google Maps over other options such as Leaflet is that a lot of people are familiar with Google Maps. So by using Google Maps in visualizations, for me as a data scientist, my client is going to probably be more comfortable with the maps I'm showing. And if they're more comfortable with other features, so it's something you don't want when you're doing data visualizations. You don't want them to focus on things that are uninformative. All right, so if my map looks different because of the background, and like, let's say the shades of green and blue are different from Google Maps, I don't want my client focusing on the shades of green and blue. I want them focusing on the details I'm presenting. And so that's why I feel like Google Maps really is a good choice for us data scientists. All right, so now I'm going to do the same map, but I'm going to zoom in, and I'm going to change the map type. All right, so I've got the same longitude and latitude. I'm zooming into 15, same scale, and I'm changing it to satellite. Let's see what happens. Oh, and so that was just to build the map. Now here is to actually render it and make it an image. All right, so here, this is a satellite image of Skydive to Land. All right, and so one of the reasons why I chose to do this is because I can explain like a very good use for this map right away. If you're going to be skydiving into land, before you jump, you need to take a good hard look at this picture, because this makes sure you know where you're going to land, where it's all right to land, where it's safe, and where it's not. So, for example, this is a runway. This is a runway. So if you're going to jump, you need to know that you can't be crossing low over runways when you skydive. We don't want collisions with planes. All right. Now, where is it that you're supposed to land? Well, there's this triangle. This is called the student area. This rectangular region is the intermediate area. This is for the more advanced jumpers. This is the gravel pit. Over here is the accuracy target pad. This is where if you go tandem skydiving, this is where you'll land unless it's super windy. And over here is the swooping area. All right, and so this image, if I wanted to, let's say I'm a skydiving instructor with students, I could use this map right now to explain where you should jump or where you should land, where you should avoid, where you should be while you're waiting to descend low enough to start your landing pattern. Also, I can explain like areas, like let's say you get into trouble that because of wind or jumping out, you're not going to be able to get over these trees. It's okay to land, not great, but okay to land at the baseball fields. All right, so now let's make it a little bit more information for our map. Let's go ahead and let's add those locations I mentioned earlier. So what I want to do, I want to indicate where's the student, intermediate, advanced, accuracy, and swoop landing areas. So the utility of this is if I was to make a large map of this and I put these labels on there, I can set it up so that when someone new to the drop zone walks up, they can see where they're supposed to land, and they don't need to have staff help them out as much. So what we need to do is I'm going to create a data frame. I'm going to name the landing areas. I'm going to put down the latitude and longitude of each location. And so now I have a data frame. Now what I'm going to do is I'm going to take these points and I'm going to plot them on that map we just looked at. Okay, so I'm going to take the ggmap command, and so this works very similar to ggplot. I'm going to declare which map I'm using, which is the keyword ggmap, the base layer. All right, so this is where things get kind of funny, in my opinion. The base layer is going to be my ggplot. Now, after that, notice I have a plus sign here. I'm going to start defining my aesthetics. So everything after ggmap is just like regular old ggplot. I define my aesthetic. So X and Y are longitude, latitude. I'm going to label things. I'm going to put down points for where I'm looking at. And I'm going to go ahead and use ggRepel because when I did this before making the video, it wasn't really working out too well. And so now we can see labeling of what's going on. All right, so we can see that the student area is that middle triangle. Swoop is over here. Swooping is the most dangerous aspect of skydiving, in my opinion. Advanced is right over the pea gravel pit. Here's the accuracy pad and the intermediate. Now, I probably would want to disperse this more before I would actually use this, but I wanted to keep the code simple, so I didn't mess with the location too much. I just left it default settings with ggRepel, and just so that you can see how to do this. Now, I could definitely, let's say I was doing something with crimes, I could definitely do the same map and start putting down like the location of robberies, or location of burglaries, assaults. I could put down like crime data all over, or any other type of data I could plot all over my map if I have it. All right, so you'll notice that I changed it from the default setting to that satellite image. Well, what options do we have? So we can use terrain, terrain background, satellite, road map, hybrid, terrain, watercolor, and toner. Toner will be our black and white ones. And these are the different map types. We have 3 different sources. We have Google Maps, OpenStreetMap, and Stamen Maps. And all 3 are good choices. Look through the different ones and pick the one that works best for your project. All right, so now let's do the same map, but this time I'm not going to label things. I'm going to change the source to Stamen, and I'm going to change the map type to toner because I want a black and white map. And here is my new map. And it looks pretty boring. It's black and white. But the reason why we like this as data scientists is that if I want to put different color dots, representing events, locations, data, then it's really easy for it to pop out for my my client to see. Now, it doesn't really show skydive land too well. It just shows the runways. It doesn't show the rest of the information. We can see the roads. We can see International Speedway, but that's about it. But that's all right as long as our client is familiar with the area we're talking about. And if I want them to really focus on the dots I put down and the colors to make them pop, this is a good choice. All right, so now let's go ahead and let's do a little bit more with ggplot. Now I want to do something a little bit juicier. So what I'm going to do, I'm going to get crime data from Orlando Police Department. Thank you, Orlando Police Department. The city of Orlando has a web page where you can download data from them, and that includes OPD. All right, I've already downloaded that previously. Some of you, and it's not a huge file, but it's big enough that I don't want to wait. So I go ahead and use data.tables, fread. This is the fastest way I've found to read data in. And fread performs similar to data.table, or sorry, read.table, read.csv. You notice I use call classes just like read.csv. All right, if you look at this data set, some of the locations are geocoded, some are not. Well, the ones that are not geocoded, I don't want for this purpose, because I just want to plot the data that is geocoded. So I'm going to get rid of anything that does not have longitude and latitude. Now, if I was doing a proper analysis, this would invoke sample bias, but for our purpose, a YouTube video, it's all right. All right, now, one thing that they do in their coding, and this is actually standard, is that they put parentheses, latitude, then longitude, and there's a comma in between. Well, I want to have the digits separate. So what I'm going to do, I'm going to use a regular expression. I'm going to use string R's, string extract, and I'm going to just grab what I want. So I'm dealing with Orlando. So all of the latitudes start with 28 and then a decimal, and all the longitudes start with -81, then a decimal. Okay, so what's going on here is I'm taking anything that is a digit 0 to 9 and grabbing everything I have after 28 decimal points, grab all digits afterwards. So if I see 28 decimal points and then numbers, grab 28 through all the numbers. If I see -81 decimal points and then numbers, grab -81, the decimal point, and all the numbers that follow. And everything else will be ignored. And now what I'm going to do, I'll skip this for a moment. I'll go back up and talk about. Oh, okay. So I'm going to go ahead and do k-means clustering on the locations of the crimes. And I'm really just doing this just to do something more than plotting dots. I wanted some kind of color, some kind of inference on there. So I decided to do k-means. Not that there's really anything that informative about it. It just kind of shows the locations of where crimes are being committed. And so I'm going to do k-means clustering. And I'm a firm believer that we should use predefined clusters or predefined centers for our clustering when we do k-means. That way my results are 100% reproducible regardless of seed or anything like that. So I'm going to go ahead. I'm going to take 3 points of longitude, 3 points of latitude. You notice I'm taking the minimum, median, and max. So I'm going minimum, middle, maximum values. And I'm taking a grid. So this is going to give me a 3x3 grid on the map. So I'll have 9 points for my centers. Before the video, I was doing k-means clustering, and it ended up that lines 4, 7, and 9 either had no points in them, or they had their clusters didn't really have very many. So I went ahead and just got rid of those just so we'd have a more even clustering. And so here is the table of the number of clusters by location. So we can see 3 is rather light comparatively, but it's enough for our purpose. And so now I want to have my cluster, and the cluster is a categorical variable. So I'll go ahead and put it as character. So ggplot treats it as a character. And now I'll go ahead and just use ggplot to plot these points. So you'll notice that I'm plotting. So I've got longitude and latitude for X and Y. I'm coloring by k-means cluster, and the rest of this is not really needed. And so here is the dots on here. So technically this is a map. You'll notice I have longitude and latitude, but there's really no connection to Orlando. So what I want to do is I want to take this and put this on top of a map of Orlando. Okay. Now you'll notice it's a lot of dots. It took a lot of time to process. So I'm not going to actually plot the dots. I'm going to plot the centers on here. So we see that we have a group here, 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 and here. So how do I do this? Well, I'm going to once again use ggmap. Now, instead of specifying zoom and the center latitude and longitude, I'm going to specify the box. So when I do ggmap, I have two options. Either I can say center location, amount of zoom, or I can specify the box that I want on the map. Here I'm choosing the box because I'm going to specify that I want, so this will be the left, the far left, far south, far east, and far north edge of my box. So I'm taking the minimum of longitude, the minimum of latitude, the maximum of longitude, and the maximum of latitude. So here, this is west, south, east, north boundary of my map. Now what I'm going to do is I'm going to set up my k-means in a data frame format. So I'm only going to grab the aspects that are useful for my purpose. So here I've got my k-means centers, latitude and longitude. I've got my within sum of squares, and I've got my size for each cluster. Now I'm going to actually plot. So with ggmap, I use this very similar to how I use ggplot. So you'll notice that I've got my aesthetic coming after a plus sign. I have my geo points coming after a plus sign. ggmap, I specify the map that I've already gotten. And for my base layer, I just say ggplot with k-means. And boom, I've got my map. So I've got 1, 2, 3, 4, 5, 6 locations. And so this is a lot more informative about what's going on in relation to Orlando. So we can see that this area, there are some crimes that Orlando Police Department are addressing, but it's not very much. Probably out by Lake Nona, because this is, I think this is 417. And, we can see downtown. And so, we can see the different areas of Orlando and, just see, oh, well, that's where our crimes are centered. Well, that's all I've got for you. Take care and goodbye.